show scatter plots, we're going to talk a little bit about how variables, x and y, go together and what sort of a format those have. We're also going to talk about something called causation. Now that sounds real complicated, but it's basically like cause and effect. If this happens, does that mean that affects this or doesn't it? We're going to talk about that a bit. We're not going to be doing the bottom here. We're not going to be doing best fit for a scatter plot. That gets into a lot of different issues, and it's something that we really don't need to mess with right now. So here's how this works. We're going to start with this thing called causation. And it says two variables have a causal relationship if one of the variables causes a change in the other. So, for instance, down here at number 1, a local grocery store conducts a study comparing the cost of the head of lettuce with the number of heads sold in a day. Do you think how much something costs has any impact on how much you sell of something? Would I sell more lettuce if I sold it for $1/4 a head versus $15 a head? Yeah. Okay. So these are what's called causal, or even if you want to write yes on something like that, that's okay. Because price, in this case, determines how much we sell. So that actually is. So let's see if this next one is. A health club keeps statistics on their members. They record the height and weight of each of their members. So is the height and weight of their members going to depend on like who comes in and who doesn't? No, I agree. No. One at a time. Okay. Oops, actually, let me swap with you.
Oh,
Thank you. Sorry for the delay. All right. So these are not causal. It doesn't matter if you're tall or wide or skinny or whatever. That's not going to have an impact on one thing versus another when it comes to our health club. So you're like, okay. Lisa keeps track of the cost and length of each of the long-distance telephone calls she makes over a 1-month period. Okay. Now, why would I want to keep track of the cost and length of a phone call that I'm making? Yeah, maybe I'm going to look to see, wow, I'm talking a little too much here, and that's causing my costs to go up. So, yes, cost could rise by length of calls. Good. So what you're basically seeing here is if what I'm doing could cause me to change my behavior in some way, if a price is going higher or if I see that my costs for my bill are too much because, I guess I'm talking a little more than I should be, those are the types of things that I'm looking for to see, and that causes a change. That's a causal relationship. And sometimes we can see that visually on something called a scatter plot. And it's just a whole bunch of points that are plotted all over the place and lets us see if two things have a causal relationship or if it's just kind of random. So, as we flip over here, got a big old chart that we're going to be making here. So here, the following chart shows the number of cell phones in millions in use in the United States from 94 to 2003. Well, I'm betting it's a whole bunch more than this now. Create a scatter plot to display the data. Now, there's a couple of things I got to do here. Typically, what will happen is whatever's listed on the top of my chart is going to be my x values, and whatever's listed on the bottom is going to be my y's. So with any good chart that you make, you always want to be able to label your parts. So I'm going to zoom out here for a second so we'll be able to see everything at once. And right now we're having some focusing issues. Let's see if I can make this go a little better. That's better. Okay. So my X with my years, I want to make sure that I label what it is down at the bottom. Bless you. And since I notice I've got, what do we got, 10 years here? 2, 4, 6, 8, 10. I think I have enough. 1, 2, 3. Oh yeah. That what we can do is maybe we can skip every other one to kind of give ourselves some more room to work with. And if we run out of room, we'll just get creative. So I'm just going to label these. That worked out pretty nice, actually. So I've got each of my values going across the bottom for my years. And if you want to write all 4 digits or just 2, I kind of intermixed them. You can do either of those. But I always want to make sure I'm labeling what it is. Just like what I'm going to label next here is up the side. I always want to label what that is too, and that's going to be the number of phones that I'm looking at here. And I also want to write next to that if it's in a different numeric format. In other words, I don't want to just write like 24 and 33.8, and they're like, people are like, they only sold 33 phones in 1995. No, that's millions. So I want to make sure I put that in there too. But here's the thing that's a little trickier. I can't just write these numbers up the edge because that doesn't show a lot of number sense. I want each of my lines to be worth the same value. So I'm looking, and I probably got about 20 lines here I could work with. Here's my lowest value. Here's my biggest one. What do you think would be a good value to use for each of my lines counting up? Would 1 work? Probably not. I'd need 150 lines. That'd take too much time anyway. How many? 20s, we could. Any other ideas? Would 5s fit? If we went by 5s, we need about 30 lines. Do we have 30? 1, 2, 3, 6, 9, 10, 11, 12. We could. Now, if we do 50, here's my one thing I'd wonder on 50. If I do 50, I'd have 50, 100, 150. All of my numbers are basically going to be in this little area right here. And that's one thing that's kind of a good point to bring up. Whenever you see a chart in a paper or a magazine or something, and it's true, you can make numbers say anything you want to. If you wanted it to look like they've barely grown at all, we could smush them all and maybe do by 50s or something and look like, well, they're not moving much at all. But if we use a smaller number, we might make it look like there's a big difference. Like let's say, for instance, here, 15 lines. Let's try 10. If we try 10 out, because I want to spread them out as much as I can so I can make sure I really see the data well. And if some of you only wanted to mark every other line or something like that, you absolutely could. Now I don't have to keep going forever here because once I hit 160 here at the top, that covers my biggest one here. But if some of you, again, if you wanted to try it with 50 or 20 or 5 or whatever it was, there's not a specific right way. It's just going to make our data look a little bit different. So once I have that, my job becomes to go to each year and approximately plot where that point would be. So like if I'm starting with 1994, I'm going to go up to 24.1, so between 20 and 30 here. And I'll just put a dot. Okay, 1995, I'd be between 30 and 40. Again, I don't have to be perfect. I'm just trying to get kind of close. 96 is 44, so between those. 97, 55.3, getting a little higher. 98, 69.2, just about puts me on 70. 99's up at 86. 2000's almost to 110. Oh, I think I'm seeing a pattern. 128. 2002, we're up to 140. And 03, we're almost up to that 160. So here's why we would do that. Now, most of the time, it's not going to possibly make a line quite this straight. You might get years that are strange where one goes down or up and is a little bit out of whack. This one's pretty darn close. We almost could draw a line straight through it. But here's how we're going to explain the data that we see. When I see this, I just want to say, well, it makes a line up to the right. That doesn't quite tell me everything I want to know. So let me squeeze this up here a bit. Okay, there's this thing that we use here called correlation. Before we had cause, now we have correlation. And it shows a relationship between two sets of data. In this case, like the year and the number of phones. Okay. A scatter plot can show 3 types of correlation with the data. Now I'm going to scooch this up for a minute. I'll come back down in a second. Okay, if it has positive correlation, everything's increasing. It's almost like looking at a line that has positive slope. And we almost can make that comparison here. So it's like having positive slope. Because all my dots, you can see, kind of form going up to the right. If they're negative, one set decreases as the other increases. But if I were to draw a line through it, it looks more, oh, it's like negative slope of a line. So for instance, maybe the price goes up, but the quantity goes down. Okay, one thing goes up, one thing goes down. And if it's just random all over the place, this could be people's grades in a class or something like that. There's really no rhyme or reason to it. We just say, well, they're not really related at all. Okay, there's no correlation. So if I had to pick one of those 3 types for my graph here, what type of correlation would you say that has? Positive, because it looks like it's going up to the right. And that's all I'm really looking for here. So not that big of a deal. So basically I'm plotting some points and seeing what type of slope they'd have. So then it says describe the correlation oops, let me pull down here a bit. Describe the correlation illustrated by each of the following scatter plots. Okay, if I tried to draw a line into the middle of that first one, test scores and watching TV, is there a type of correlation with those? Could I draw a line that would be close to being right in the middle of all that data? What do you think? Yeah, which direction's it going this time? Looks like it's going downward. So this one would have a negative correlation. In other words, it looks as though test scores decrease as watching TV time increases. So as one value is going up, the number of hours watching TV, the other thing goes down, the test scores. And that's how negative correlation would work. Ooh, snowboarding competition and participants. Any correlation on this one? Being told no. Anybody else? Is this a no correlation? I don't know if I totally agree. It looks like, except for that one year when it went down, it looks like it's typically going up. So it looks like as the years increase, so do the number of participants. So we've got a positive correlation that goes here. Now, sometimes you may find yourself wanting to even draw a picture yourself with this. Like, why would I want to draw a picture? Well, sometimes they may not give me a picture, they just may give me the information. Identify the correlation you'd expect to see between each of the following sets of data. Okay. The temperature in Houston and the number of cars sold in Boston. Now, are those things related at all? No. No. Oh. Okay. They're not related at all. It doesn't matter what the temperature is in Houston for how many cars I'm selling in Boston. That's ridiculous. So, that's what we're doing here. Okay. So if there's no relationship with them, we just say it, we call it no correlation. Now, this one I have a feeling is going to be a little different. The number of members in a family and the size of their grocery bill. Yes, because that would be positive correlation. Because as the number of members increases, so does their grocery bill, more than likely. So if they're both going in the same direction, that's positive. Let's see. The number of empty seats in a classroom and the number of students seated in the class. What happens as the number of empty seats rises? The number of students seated would decrease. Because if you're standing there and all of a sudden you stand up and go walking over, it's like, ooh, now I have more empty seats than I do seated. One goes up, one goes down. What type's that again? Negative. We do one of each. When one thing goes up, one thing goes down, we've got ourselves some negative correlation. All right, last one here in the examples, because like I said, we're not going to do line of best fit here. Choose the scatter plot that best represents the relationship between the number of minutes since a pie has been taken out of the oven and the temperature of the oven. Now, I'm going to assume we turned off the oven when we took the pie out of it. At least I hope we did. So which one do you think would be closest? Okay, we're starting on this one. We've been baking a pie. We're going to take it out of the oven. And I'm, again, going to assume we're turning off the oven when that happens. So is the temperature going to get higher or lower? It's going to get lower as the time goes. So anything where I see it going higher, okay, that doesn't make sense because it's not going to go up.
I think it's B though.
You think it's B though? All right, well, let's see. Now, why would you say B? Because I tend to agree with you, actually.
No.
I do.
Was it going high at first?
Yeah, it is.
Okay.
It goes down.
Yeah, and then it went down.
That's right. And the other reason, yep, and the other reason I'd kind of agree with you on that is, because it says since it's been taken out of the oven, I'd hope it was warmer when the pie was getting baked than when I turned it off down here. But some of you that might argue A, I could also see your argument there. You're like, well, it's hot when I take it out, and then it's just going to kind of get less.
When you turn the oven on.
Yeah, once you turn the oven off, it can start dropping in temperature pretty quick. So I would go with either of you on this, but I'm still tending more on this because it'd be hotter before I turn the oven off. So I'm going with B, but if you go with A, I say that's a good argument. But that's what we're doing with these scatter plots. We're just not putting a bunch of points on a line saying, woo, I'm done. We're actually using it to come up with a relationship. So here's what we're going to do with it. You have got a worksheet there that we're going to do a little talking on here about doing correlation for. And again, you're just looking to see what type it is. So let's see. Let's do a couple of these. Let's do I'm going to do 1 and 3 with you here. So on the homework, what type of correlations looks like we have on number 1? Is there a rhyme or reason to my dots? Or are they just basically everywhere? They're just basically everywhere. Okay? Because they should make something that sort of, a little bit, could resemble a line. Because like if I drew a line through here, I got a bunch of dots and all these other places that aren't even close to my line. However, on number 3, now you could give me 2 arguments here that I'm going to go with you on. Anybody care to fire an idea out on what they think? What type of correlation do you think we got out here? I agree. Because even though you're like, we're only going through 2 dots, they're all kind of going the same direction though. It's not like some left, some right, and all that other stuff. But so that's all I'm doing here basically with my scatter plots. When I get down to number 7, and I'm not going to plot every single one of these with you, but again, just remember, ooh, it's even done for you already. That's nice. X and Y.
So do we do the same thing as
It's sort of like what we did as far as back when we were doing these. We're going to basically plot these on here. So like if I slept 8 hours, score was 83.
Only like positive and negative points.
Oh, trying to figure out the correlation with this one? Well, let's see. This one, it looks like we're actually just doing the plotting. But I would like you to tell me which type of correlation you think you're seeing. That would be awesome. Because that kind of gets us some more practice. And you're like, well, wait a minute, some of these are the same one. I know. But as you do them, I just kind of check them off along the top there and then try to figure out, once you have them plotted, what type of correlation that you've got with those.
Get on your face, please. They told you a lot before school. So.
What's number 6?
Well, now the number 6 to me, anybody got an idea what number 6 here? I don't know, they all look like they're going up to the right? No. They all look like they're going down to the right? So if it's neither of those, what's it got to be? No. And then I believe when you flip to the back, there's one more for you to go ahead and get plotted on your graph. And once we do that, let's see here. Identify, oh, okay. Plot up top, and then on the bottom of the back, it just says, you're just going to say which type it is. So like, let's say here, let's do 8 and 9. Do a couple here again. The number of hours a person has driven and the number of miles they have driven. Positive, because as you drive more hours, you drive more miles. Nicely done. Let's see. The number of siblings a student has and the grade they have in math class. None. It doesn't matter, because you can be an only child and have a good grade. You can be an only child and have a bad grade. You can have 10 siblings and have a good grade. You can have 10 siblings and have a bad grade. It doesn't matter. But that's what you're doing down here on the bottom, and then you're going to be set. Now, like I said, you're going to see some more of this in these reviews over the next couple of days that we're going to do. And that's getting us ready for Thursday with the test. Now, one last reminder, with our new homework, the way we're doing things, okay, I'm just going to keep that list going on the back board. But by Thursday, when the test is, that's going to be the deadline for anything that's on that back board for you to have into me and then to get back. Okay, so please make sure you're doing that. And if you've missed it all, either those days last week or anything like that, okay, just one sec. Those 2 days for last week are over in the folder. Make sure you grab those. Which, up here? We're just plotting the points.
Yeah, but there's like, no 1, no 2, no 3.
Well, let's see what's going on here. Oh, I see what you're doing. Okay. Here, my water consumption, they flipped them on us. That wasn't nice. It's going to be my X, and my temperature is going to be my Y. I'm not sure why they had to put their day category in there too, because that makes it trickier. So like on day 1, my water consumption is 48. The temperature is 99. Or like then my water is 27. The temperature is 85. And I'm just going to plot them that way. So yeah, the day itself is not going to be one of the things that you're plotting. It's just going to be your water consumption and your temperature. And then again, look at it and see what you think is going to be the correlation that they have, if there is any.